So I think we'll probably have a few people file in, but might as well get started. We're a few minutes after. Similar arrangement to this panel. We'll have some Q&A at the end for about 15 minutes. Feel free to grill those three during that period. So what we're transitioning into is resource planning, the age of soft grid, targeting investment in energy efficiency and distributed energy resources. So the reason that we brought this panel out is we've seen a lot of focus mainly around Hawaii, now starting the last couple months in California, and through some of the work with Reforming Energy Vision in New York, as well as quite a bit of work Maryland Energy Administration and Maryland PSC has worked through with the Maryland utilities around putting energy efficiency, putting potentially distributed energy resources in the hands of distribution utilities and third-party providers, and trying to have a more holistic understanding of the effect on the grid itself. On the distribution side. So it's been a very interesting piece because from traditional standpoints, there hasn't been that ability to model dynamic resources or dynamic devices. And we'll get a little bit more information on that. But you're looking at, in many cases, a whole new area for many utilities trying to get towards that piece. So with that, we have Kyle Haas, a Senior Policy Manager for Energy Policy Manager for Maryland Energy Administration, John Fedorovich, the President of Electric Distribution Design, or EDD. And we have Surya Kular, the CTO of ADMS Solutions with Landis & Gear, formerly with Gradient. So to start us off, when describing that change a little bit more, how drastic is that adjustment from running one single time period or running models that are based on single frames or minimums and maximums in certain conditions that could bring down the system to more time series, more dynamic models? So start with you, Surya.
So traditionally, the planning or asset planning the system has been done using much less data. So typically using peak loading scenarios or low loading scenarios, certain types of scenarios, and then doing what's called feeder by feeder, substation by substation type of analysis, taking one piece at a time and doing planning using that approach. What I see happening is multiple different things. Number one, looking at the distribution system as one thing, like holistic, the whole system as one piece instead of one piece at a time. So that is one piece that I see. The new tools will have to incorporate those things. I mean, whether they are new tools or enhancements to existing tools, I mean, it's going to be all over the map. The second one is using real data. So utilities already have OMS that are storing all the outage history, SCADA or historians that are storing real measurement data, and AMI, MDM, all the meter data, and GIS, constantly tracking system upgrades and everything. So the new tools will have to bring it all together and use that. And when you bring in AMI data and loading history, it's a lot more time series kind of approach rather than looking at one snapshot, especially with all the renewables and intermittent resources and storage, which is even much more different than both of them. It's going to be a lot more time series based. Peak load may not be suitable for analyzing the PV. It may be high irradiance time. So it is incorporating those kinds of things that has to be incorporated. And another thing that I call real-time planning. I mean, currently the planning process involves a lot of data preparation, collecting the data, a lot of grunge work that planning engineers don't like to do. And a lot of those things are going to get automated because everything is based on real data. So that is the third part, and probably the fourth part, whichever part it is. And the final piece is going to be more cost-benefit analysis. I mean, making sure, so till now, engineering analysis, purely engineering analysis, planning analysis, bringing in financial side, cost side of it, the benefit side of it, and putting all those things together and giving dollar value to many of the engineering decisions that are being done. So the new tools will have to incorporate that. So those are the things that I see happening in there.
Yeah, so, it's loud. So really what it's about for me for this conference is it's taking all this data that all of you are generating by putting your devices out there, whether it's DER, storage, whether it's Barentech devices, whatever it is, and being able to attach that to a model and use it in your analytics. That's really the key to making this soft grid actually come to life. And that's really the technology that we're trying to put forward. And I know Griddian happens to probably be our only competitor in this space. I think there's only really 2 of us that are doing these large integrated system models, so I think it's interesting that we're up here. But really what I see happening, and when we talk about drastic, the drastic thing that has to happen is that for my whole career, am I off?
Apparently you're off, yes.
I'm off, but I have a big mouth, so it doesn't matter. So for my whole career, which has been spent working in the utility industry, half of the time for utilities as an area operating manager, an engineer, and an energy manager, we focused all of our energy on running a passive distribution system. And really what we're trying to do by bringing renewables and storage and all these other devices in, we're trying to run an active distribution system. And that's the change that I think we really have to get our heads around.
And just to echo your point, there are 2 folks up here who are able to do these advanced models, these advanced scenario modeling. And hopefully from my perspective, and what I would like to do at MEA is to offer an opportunity and to help our utilities use these tools that they have, understand the tools that they have, and to then implement them. So you can analyze the data, but our goal is to help them then use that data and to help it ultimately impact rates and really enable the grid to facilitate and incorporate distributed resources. So while these guys are really focusing on the technical component of it, what I'm particularly interested in and what I'm excited to talk about is how we really drive that into something that the utilities can use and want to use moving forward.
So one thing I do want to mention, actually, so we had it's been mentioned many times, we had our executive council meeting on soft grid yesterday, and one of the exercise we had at the end of the day was, what are the 10, or what are the 5, and we all listed the other 5 as well, what are the 5 most important use cases to the council for analytics? And what's interesting about this panel is 2 of the 3 were either near real-time simulation of renewables. The other one was distribution planning. And we had some very, very, very avid lobbying for that from the CPUC member, actually. But I just want to mention that, and looking at that on the distribution planning side, how is that actually occurring right now when Maryland right now has very, very strong efforts around energy efficiency? And there's been recent talks, and I believe you guys were one of the major commenters on a microgrid paper that came out, providing utilities with the ability to own distributed energy resources for public purposes. How's that being conducted today, and what might be the major change in the future?
So to give a little bit of context for this, because I understand that there's folks here from every part of the country, and there are a lot of different scenarios, but we currently work in a deregulated market, and prior to 1999, that was actually not the case. In that scenario, prior to 1999, the utilities of Maryland actually worked with the Public Service Commission to develop integrated resource plans, which would help them then develop strategically placed assets and to upgrade the grid. Utilities at that point owned generation as well as distribution assets, and they were all vertically integrated. So in 1999, the legislature moved us to a deregulated market, which really focuses on the PJM interconnect and the markets associated with that, where now you have third parties, not utilities, who are owning all of the generation assets. And this allowed consumers to choose energy service companies from a competitive market. And while this is great in terms of offering more options to consumers, the challenge there is because the utilities are no longer developing those generation assets, they're limited to strictly distribution assets. So now you have 2 separate parts of your energy system, and it becomes much more difficult to strategically develop projects, including targeted energy efficiency, that will ultimately lower the cost of the grid and running the grid, so that could then be realized by consumers. So you sort of have this challenge of how do we offer as much options to consumers while still developing the grid in a way that makes sense. So in today's deregulated market, the utilities procure this power, procure power twice a year for 2-year tracks. And the bidders often, these bidders offer soup to nuts solutions, and the capacity constraints, line losses, all of these other geographic and time-based variables are incorporated via PJM Interconnect's energy markets. And the real crux of this, and we can talk more about it if folks are interested, is in locational marginal pricing to account for the time and geographic component of that. But the challenge here is the level of granularity and the speed at which the data is able to be accessed and then turned into something that folks can use. So while the system begins to account for the true value of the resource, we're currently looking for an opportunity and to leverage these resources. And as I mentioned in my first statement, to work with our utilities to say, this is the system that we want. This is the system that we want to develop. And how can we offer you the tools and the business models that not only make it so that you understand what these what offerings these companies have, but also how do you make it economical within your business model? And I think we'll talk a little bit more about that.
And so the key there really is that's the transmission way of doing it. When you have large resources, you can develop the model doesn't have as many points. You'd have a much easier way of planning upgrades because I'd need a 138 kV line to attach this 50 megawatt solar, 50 megawatt small natural gas plant, et cetera, or 500 megawatt plant. And the alterations are something that's ongoing.
Yep.
Right? Surya, if you want to comment.
I agree with what Carl was mentioning. So don't have any specific comments on that.
John?
Yeah, so one of the things that we're doing is with our model, once we have the detailed model of the system, what we're doing is we're looking and trying to build up the resource forecast from a feeder level. So if you have enough detail in your model where you've got all of your AMI smart meter data on the model, you've got all your distributed resources, you've got all of your batteries on that model, now you can start look at that feeder as a separate entity, and you can do the same kind of forecasting and scheduling of the resources on that feeder based on the load forecast, based on the generation forecast, based on what you're trying to do with the storage that you have on that feeder. Like, when do I charge it? I want to charge it when the LMP is low. When do I discharge it? I want to discharge it when the LMP is high. So writing those kind of algorithms into a schedule for the feeder, and then ultimately being able to aggregate those feeders together. That's where we see things going now. Are we there today? No, but we are doing those individual feeder, what we call forecast, schedule, monitor, adjust. And we really do it very similar to what you do on the transmission side. You do a day-ahead schedule, you do an hourly schedule, you monitor in real time. If you have to make an adjustment to your schedule in real time, you do that.
And one of the main values for that, at least initially, is being able to say, if I add X, here's what happens, here's how it'd be affected, right?
Well, yeah,
It's taking into consideration saying that the LMPs came into picture in transmission side, basically saying that generation or load is the value of generation or load is location specific, based on how the network is built. Mm-hmm. The same thing exists on the distribution side too. For example, a smart inverter has more value at a location which is more voltage constrained than closer to the substation, right? So it's basically quantifying that benefit and putting a dollar value into it. And it maps into whether do we need to have a market on the distribution side, just like with the transmission side. Or whether do you want to take LMP at the transmission substation level and flow it all the way down to the customer level. Mm-hmm. I mean, that is ultimate goal, or blue sky thinking, but how far do you go? So it's accounting for all those things is what a value of it, and incorporating that into the plan.
Yeah, and that's when we say that's a little ways off.
Yes.
When you're talking about LMPs, I think most things I've run into, you're talking at least multiple years, and the big pusher for that on the kind of independent DSO and pricing models, it seems like right now, John Wallinghoff came out and said we should have distribution entities separate, and have
Yes.
the person managing the equipment separate from the person managing the system. So.
Yeah, but even recognizing that fact that the renewables or any kind of resource is not created equal. It depends on where you place it
Yeah.
in the distribution system, inside the feeder, may not be even the transmission side. And incorporating that consideration into the system is what is important too.
Okay.
May not be the markets yet, but
So one thing I do want to touch on is, are there, when you're moving into planning for more dynamic resources, are there any parallels right now with IRP planning, like with energy efficiency? Is there anything that utilities can work off of? Is this something that we're going to have to kind of start from scratch on new systems? Not necessarily start from scratch, but alter systems tremendously? Or is the process going to be possible to maintain the current integrity of the IRP process? So you're looking at a selection of distribution feeders or a substation.
Yeah, I mean, the way I look at it is, you have to start, again, if you make that shift in your mindset that we're no longer going to manage a distribution feeder as a passive element, it's going to be an active element, then, you basically build from that. You build that up into your integrated system model. You build all the pieces and the components together. You still have to, you're still receiving energy at the distribution substation level where, the transmission is feeding in. So I think, the IRP is going to have to integrate with that. But I think if you do it in those two layers, I think you'll have a much better chance at coming up with an answer than if you try and, mush it all together and, try to make sense out of it that way.
Mm-hmm.
yeah, and from a planning sense, there are some parallels between demand response, energy efficiency, and PV or everything else, in the sense that both of them result in load reduction, directly or indirectly. However, if you are putting it into, the considerations are different, because demand response and energy efficiency, they're more controlled, but if you look at PV or wind, and those kinds of resources, they are intermittent and have different effect than a demand response or energy efficiency. So if you do a traditional planning by looking at just some snapshots in a year, they all look similar. But if you look at it from a time series kind of point of view, they are different. And if you look at PV, solar, and things like those kinds of resources, they're intermittent, and it has its own effect that are dynamic on the distribution system, like load fluctuations or voltage flickers and all those things associated with them. And storage is another beast, in the sense that it can be a generator or it can be a load. And when does it become a generator? When does it become a load? Where do you charge and where do you discharge? And that can also skew which reference points you use for your planning too. So that's where they differ, but the common point is that both of them are more like load reduction.
One thing I do want to ask you, Kyle, because as I said earlier, you guys, what was it, 2008 or so, you committed to 15% reduction in peak, 15% reduction in overall energy use. How, with recent thoughts and the push towards potentially, not necessarily incentivizing microgrids, but enabling deployment of microgrids a bit more, how is MEA looking at EE and looking at feeder level type pieces? Because these programs largely in the past have been just get it across your territory, right?
And to a certain extent, that some of that still exists. And I think some of the efforts that we've had at MEA have begun to speak to, and the Public Service Commission as well, have begun to speak to how you do this. But for me, as I mentioned in the beginning, I really want to see the utilities as the enabler, as being driven to leverage these opportunities and to make it work within their business model. And I think Bud actually made a really great statement earlier that I'd like to echo, where he mentioned that how can you package software like this up into a big piece of iron so that the utility can then take that to the Public Service Commission and say this is a relevant expense? Because right now, within at least Maryland's regulatory paradigm, the utilities come to the Public Service Commission and they say, here's our system, and this feeder, and this feeder are, the peak demand is beginning to reach the capacity of that particular feeder, that particular substation. So obviously it makes sense for us to upgrade that substation or that feeder line. and here's how much it's going to cost. And the real challenge there is that ultimately the utilities are compensated as a percentage of the expenditures that they make. So my question ultimately is, and in response to your question, is how do we make energy efficiency, distributed and enabling distributed energy resources a sustainable business model for utilities, and to then say, all right, you're no longer seeing these defections from the grid as a threat to your business model, but this is what we're challenging you to do, and here's how we are going to incent you or to incentivize you to accomplish this. You're our partner now in achieving our sustainability goals. And whoever manages to crack that nut, and I think New York has made a really good start and started the discussion, but I think whoever is able to really develop a business model where the utilities, with all of their assets, with all of their knowledge, whoever is able to really bring the utilities on as a partner and make these investments economical, and make public service commissions and public utility commissions across the country really understand where that value lies, where it lies for the ratepayer, and the state as a whole. I think that's really where you get to the point where energy efficiency is no longer sort of, well, we have goals for the state and we're complying with the Public Service Commission. We didn't do it this time, but we'll do it next time. When you're really able to bring them in as a partner to accomplish those goals, I think that's really where we'll be able to move forward.
So with that, I do want to touch base on New York. So one thing that becomes particularly interesting, and I know this was a topic of discussion, is if it's California as well to a point, although I haven't gotten necessarily as verbose about it yet, is looking at a system like this as a transparency measure for third-party providers. Is how the tools that would be required for that, is this something that'd be available? Because in reality, nobody has this data other than the utility, correct? Because it's system-level data.
Yeah, so I'll take that one if I could.
Yeah.
So we have a customer. We actually pitched this transparency idea to on one of the early DOE sunshots, and we weren't quite ready for it, and they didn't give us the funding, and it was right that they didn't, because we weren't ready to do it. But you'll hear me talk about modeling a lot, modeling. I was at a workshop last Friday in Berkeley with all the engineers from California utilities, and we were in a real techie wallow there, but even they got tired of hearing me talk about models, because there's a general feeling, I think, in the industry that building these detailed models of the system is not possible. It's just too hard to do. And we have a model built now for one of our Mid-Atlantic utilities that contains 15,000 DER on their system. Now, I heard yesterday that I think California has like 200,000 PV deployed across the state. So this 15,000 on this utility is probably pretty equivalent percentage-wise to what California has. And so what we have is we've got a model where we've got all of the smart meter data, we've got all the DER, we've got this thing called the load gen database where we add the load back in to offset the net metering effect. And we've got all of the DER interconnection criteria based on the IEEE 1547 committee built into the model to do the analysis. Now, right now we have it set up in a fashion we call semi-automated. So as a new DER request comes into the queue, it gets added to this database of 15,000 DER. And if it's a pretty small, simple request, there's no clustering behind a transformer, et cetera, it flows through pretty easily. If not, it'll go to an engineer to do the analysis in the model. But there's really no reason why, if you gain confidence that this model is working and it's effective, that you couldn't just automate that process and put a layer on top of the model. Don't expose the model to the developers. Just put a layer on top. It can be a map layer of whatever variety map you want. Developer comes in, wants to put a 20 kW DER at 123 Main Street. It triggers the analytics in the model, to tell you whether you can do it or not. And that's basically where we're at. We've got the model done now. We're going to probably take another run at going after the money to do it.
And so one of the biggest things there is now you have a system that instead of having a 3-month interconnection, a study potentially, and this would be for larger systems generally, you'd go down to, you're talking days, right?
Yeah.
Yeah, because what,
Removes the engineer from the.
right, for the larger studies, you would probably get a conditional approval, and it would go to an engineer. But even, I mean, the reason we started working with this particular utility in the first place was specifically to lower the cost of interconnection requests, because they were spending a lot of money on interconnection studies. Interconnection requests was taking a long time. They're getting beat up by the commission. They're getting beat up by all of the solar developers and their customers. And that's how we got a chance to work with this utility in the first place.
And an important thing about what he just said is the fact that all of that costs money to a developer and to ultimately an end user. And we've seen that add cost to projects. And ultimately, that can, in some of the fine margins in these projects that are being developed, that can ultimately mean the difference between a project being undertaken or not.
And it's a big operational risk for that matter, because you have resources sitting there that you planned out that may or may not be used. So we got about 15 minutes left. I'll open up to audience questions. Got a couple runners going around. Oh, and right in the middle. Blue light is right behind you, so it's difficult to see you there.
Yeah, I think it was interesting, the discussion that you made, about the, trying to incentivize the utilities to shrink. Because that's really what it is. I mean, there's no two ways to equivocate about it. It's that, as distributed power and energy efficiency grow, we'll have less demand for the utilities. And, as public companies, to some extent, that's against their DNA. And I think the fact that as you mentioned, they get paid based on how much money in other words, that they get what they spend plus a premium because they're, to some extent regulated. It reminds me of why we see, if you watch a football game, all you see are insurance commercials. You'd think that everyone was constantly shopping their insurance. But why do you see them? Because they get a premium to spend money. That's their business model. The more they spend, the more they make. And I just think that and again, I'm just being fundamentally, as this is kind of the early days. I mean, distributed energy really isn't more in a meaningful way in terms of solar and wind and other systems, isn't really more than 10 years old and is really starting to catch on now over the last 5 years. I just think it's going to be a challenge institutionally. And you can the question part of this is, if you can counter this argument, I think it's going to be hard institutionally to sort of, as time goes on, sort of say, hey, you can be a good lean company and you can be a good lean profitable company, but you're going to be a good lean profitable smaller company. I think that's going to be difficult to institutionalize. That's just my gut.
I'm going to take it right after you, though.
Okay, that sounds good.
I'm claiming
I'd like to be careful about the concept of shrinking utilities. And the way that I would like to look at it is, in Maryland, we have densely populated areas in central Maryland, whereas the western part of the state and the eastern shore are a little bit less populated. So through the 20th century, we challenged our utilities to electrify the state. And the goal there is, all right, utilities, we need you to get electricity out to western Maryland and the eastern shore. So it made sense, conceivably, to say we're going to pay you for each mile of line and each substation you put out there. Well, now I think we've put utilities to a new set of challenges. And those challenges are integrate distributed energy resources, make the system more reliable. And that's very important in Maryland because as you see events like Superstorm Sandy, the derecho, that sort of thing. So rather than framing it as we are asking them to be smaller and you're going to deal with it, I like to look at it as we're challenging you with new challenges. We're asking you to do new things. So to continue a business model based on hardware or solely on hardware sort of doesn't make that much sense. So I agree with you. Any sort of monumental change like this where you move from one business model to another is going to be something that's challenging. But at the same time, it's not about asking them to go away or anything along those lines. It's the idea of we're putting forward new monumental challenges. These are not easy things to deal with. So that's the way that I kind of frame it. And that way we can go to our utilities and say, look, you're going to have jobs. And conceivably, you could make more profits if you were really, really good at lowering the cost of energy or enabling more users. And I guess that's the way that I would frame sort of my prior statement rather than saying, you're just going to get smaller and you're going to deal with it.
Yeah. I could talk for multiple hours with no one actually talking at me, speaking with me on this. But no, I think the big thing you have to realize, and this is the frustration I run into with utility business model discussions, is utilities have many businesses. There are wires businesses, and the medium voltage wires and low voltage wires aren't going to go away. I mean, you can take my word for it. You can take the entire Grid Edge Council's word for it. Like when we got into grid defection, it's not about defecting from the grid. It's about having a lot less energy. There's a lot of challenges with building the infrastructure with less energy moving through the wires. And those are definitely a problem, but there's still generation somewhere. Someone's selling that. There are inherent values that utilities have. They're old organizations with huge asset bases that are really good at raising capital. So there are utilities trying to address this, and there are some areas, Maryland recently said, hey, there's a potential there for microgrid distributed energy resources to be owned by the distribution utility. APS is applying to own residential solar. It's been something that's happened at munis and co-ops for a while now, actually, for distributed generation in general. But the business has to change, not necessarily go away or get smaller. It's just you're reallocating people. I don't know if you guys want to go beyond that.
I hear this a lot too, in the sense that utilities are going to go away. I mean, everything is going to be locally generated. Customers will generate their own power. They'll basically use utility as a backup. I mean, that is one extreme scenario, and what is there now is the other extreme. I think it's going to be somewhere in between, where the model is going to be, there is going to be central generation, there is going to be distributed generation, there are going to be microgrids, and utilities basically have to change the way they operate to accommodate all of these things. I think that is going to be the final, like a balanced kind of way of where things will settle down. And I don't think utilities will go away. I mean, it depends on the region too. In some regions, probably there will be a lot more local and distributed generation compared to central generation. But in other places, there is going to be a lot more central generation too. I use this IT paradigm. Like there used to be mainframes and then all PCs and everything else. Now we are back into this cloud infrastructure, where hosted applications with little tablets and everything else consuming. So it could go back to central generation again. It's going to be a balance of those three things. Yeah. That's what I think.
We can go to the next question. How's that? So I think we had that was the most recent one.
Thank you. Craig Lewis with the Clean Coalition. The Clean Coalition works with a number of utilities on modeling distribution grids, and we've used a number of different tools. We always come to the same bottlenecks in the process, which are, number one, making sure we're working with clean data sets. There's a number of different data sets that need to get imported into the modeling platform. And number two is we haven't found a single modeling tool that is very mature. We're at the early stages of modeling distribution grids from a power flow standpoint. And so my question is really to Surya and John. In terms of the modeling activities that you gentlemen are involved with, when you go to a new utility, what's your process for rolling out your model onto a distribution grid, and how quickly and efficiently can you do that?
Yeah, so let me go first. So the first thing that we hear when we get to utilities is that most of the people say we don't have the data. But utilities do have the data. It's in GIS, it's in some place, typically in a GIS. And you're talking to engineers, so engineers want everything to be 100% accurate. I mean, it's very, very difficult to get to that point because it will take a lot of investment to get to that point. But for most of the planning and even real-time analysis, 95% accuracy is just fine, okay? And so we go through multiple steps to clean up and make the data get to that accuracy. The first one is take the GIS data, build what is called a connectivity model, which is basically how the assets are connected together and figuring that out. And then look for any obvious errors. You'll be surprised to see some errors where there are some typos. Somebody will enter some 99999 into a field, and you don't know what it is. So figuring all those things out, that is the first step. Okay. Once that one is done, then there are multiple steps to go through, figure out what we call topology processing. Okay, so distribution systems are most of the places. The feeders are radial. You start from the substations and feeders go out. There are interties and everything. That's okay. So you make sure that the system is in that. Wherever the system is radial, the model is radial too. Okay, and there are no loops and there are no network where they are not supposed to be. So that is the second part. And third part is what we call island detection. Island detection is making sure that there are no unenergized parts in the system, and you need to figure out why it is. And this is an iterative process. You may have to go back to the GIS, fix the data, and it typically needs to be done once. You don't need to do it every time. And you go back and fix the data and do this connectivity. And the third one is phasing. Typically, the phases are all mixed up. So you need to go and validate that and verify that the phasing is right. And then comes the simulation phase. With that, you have a load flow model. Okay? From there, you run actual load flow and see what the voltages look like. If the voltages are all over the map, which doesn't reflect the real scenario, because there are AMI systems that bring in voltages, may not be real time, historical voltages. You can actually compare your calculation against those values and then see how much they make sense. They won't match 100%, but our experience has been that even in those cases, we have been able to make models accurate up to 90 to 95% accurate, which is more than sufficient for any planning type of applications, even many of the real-time or close to real-time applications. So it is an involved process, and you have to work with the GIS to modify it and change it, and also may involve some process within the utility to how they enter changes to the GIS. There may have to be validation that happens along with that. So, but the models can be built. I mean, we have built models for multiple utilities for the complete system, like 600,000, 2 million customers, that kind of a system. It can all be built, analysis can be done. So it is not a technical challenge anymore.
It's a money challenge, though, definitely.
Yeah, there is that one. There needs to be motivation too. And
Yeah, I'll go quick. Yeah, a lot of a lot of serious comments. The one thing that we do that may be a little bit different is we have a different topology, approach to topology. We actually, if you think of our model, when you look at our model, it looks like a GIS. I mean, it has all of the lines and poles and transformers. We can go down to the secondary, the meters, et cetera, over geospatial background. But what we do is our topology includes our physics. So when we're building our model, we're checking connectivity right at that point in time. But that has been our primary focus over the last 3 years, or one of our primary focuses, is to speed up the model build process, because nothing will kill an IT project more than having it take a long time. So that's been one of our focus areas.
Yeah, and it's been a massive pain across the board, even for simpler type processes. If you're just implementing a DMS, the GIS cleanup has been taking years.
And I think, again, not to tell too many war stories, but at PP&L in the mid-90s, when I was an area operating manager, I led a project. We put in Esri's, we were Esri's third customer. So I have a long history with GIS, but it's 20, 25-year-old technology. The topology model that you've got to go back and scrub and clean and re-scrub and re-clean. We have one client who has 400 designers making changes to their GIS topology every day. They have a big capital project going on. They estimate that they get 10 errors a week from these 400, so they get 4,000 new errors a week introduced into GIS, and we can do better than that.
Yeah. So we have about 2 minutes, so if somebody has a question that they think can be answered in less than 2 minutes, we can take it. Otherwise, we can believe we have a break after this for about, nope. We have a keynote next. So, one right there.
So I'll make it a yes/no question. I wanted to loop back on the statement regarding utilities living in this world where there's less energy moving through the wires, but it's clearly, from the title of the conference, a world in which there's a lot more data moving through the wires, or through the wireless mesh.
Different wires, usually.
Well, it's a wireless mesh, so there are no wires, but there's a lot of data, right? And the question is, yes or no, is there a real opportunity for utilities to leverage that as one of the new or maybe current businesses they're in to generate a renewed uptick in the actual utility revenue from this new product or products built around the data itself as opposed to the energy.
So just to clarify, are you talking data, providing data services to customers, meaning being a telecom provider, or are you talking data in the way of provisioning data to a storage vendor that wants access to a transparency model, a distribution model, for instance?
Well, maybe the right way to ask that would be, there are clearly lots of innovative companies taking that data and starting whole new businesses. The question is, will the utilities manage to plug into that themselves, or will it all go to innovative new businesses?
I don't know who wants to go first.
Oh,
Kyle,
man.
you're smiling.
Look at me.
You can't smile ear to
Yeah,
ear
I
and assume you're not going to talk first.
I think we're moving in that direction. I think right now we're challenged by sort of the existing paradigm that I described earlier. I think there's obvious value in this, but the question is sort of, and we continue to investigate this, is that something that in the existing paradigm they're able to and I guess my answer is we could probably be doing it better.
2 sentences.
2 sentences. I think the utilities have enough to do to figure out how to run this active smart grid, to shift from this passive grid to this active grid. And I think if selling data services can be built into the new revenue model for doing that service, that I think, would make sense.
Yeah, I agree with what John said, basically. And again, there are going to be 2 different answers again.
2 sentences.
2 sentences, or do yes or no?
You can do yes or no, that's fine.
Yeah,
You
yes.
can do maybe if you really
yeah.
want.
Yes or no?
Yes.
That's the answer.
To put it really simply, I would say there's possibilities, but it's not going to be their primary business. I don't think anybody's assuming that. And I think the retail businesses, the retail utilities, definitely.
Yeah.
T&D, it's a little harder. So we've gone over. So turn it over to you,
So-
Rick.